Okay, now this is a walkthrough of the review solutions for the normal distribution quiz. First of all, I'm going to go ahead and use stapplet for the calculator. Sadly, my emulator is not working on this computer, but you have the keystrokes to the right there. In fact, let me go ahead and highlight that. So your keystrokes are right here, and it tells you what to do. Remember, when you have to do infinity, make sure that you do 1 EE to the 99. If you don't know how to do that, feel free to bug me. Okay, I would show you, but the emulator software is not working on this computer. Okay, so we have a study of elite distance runners found body weights to be approximately normal with a mean body weight of 63.1 kilograms with a standard deviation of 4.2 kilograms. So again, this is approximately normal, and that means I can use a normal distribution. Here's my mean, and there's my standard deviation. So I'm going to click on normal distributions in stapplet and put in my mean. Here, I'll zoom this in just a touch, just so I know this is a giant screen here. And you can see the mean is 63.1, and standard deviation is 4.2. Plot the distribution. Now I'm asking you what percentage of weights are 60 kilograms or greater. So that would be an area. Area is percentage. Okay, so let me go ahead and make a note. Percentage means area. All right, let me make that in red and draw a little arrow. That's what that means. Okay, so percentage means area, and I have calculate an area right there, so I'm on the right thing. And 60 kilograms or greater, so I'm going to the right of a value and I put in 60. Calculate the area, show the labels on the plot, and you can see that the answer is 76.98. If you have a different number of decimals, it could be 77%. Either one works, okay? So that's number one for partner A. For partner B, our mean changes to 92.3, and our standard deviation is 12.5. And I want to know what percentage of weights are 100 kilograms or greater. So I put in 100, calculate the area. Make sure to have this checked here, okay? And you can see that the answer is 26.9%. Okay, going back to number 2. I'll tell you what, I'll do B side. I'm going to zigzag. B side and then A side. So I still have the 92.3 and the 12.5. But I want to know what percentage of weights are between 95 and 105. So that's between two values. I put 95 and 105. Calculate my area. There it is, 25.97. Now remember, I'm showing you the work that must be shown here. So if you are using stapplet, I need to see the area marked, I need to see the model, and I need to see this and this shaded. All right, so that is work for the stapplet. If you're using the calculator, I need every little bit right here. All of that is calculator work. I don't really need the z-scores. I used to require it. It's good for you to understand z-scores, but if you're in a rush, it's not necessary. Okay, so now I'll come back to partner A. And we have a different mean and standard deviation for that at 63.1 and 4.2. And we want to know between 65 and 70. Calculate area. And boom, 27.53, basically matching the answer I have over in the key. Next, number 3. What is the weight cutoff for the top 20% of runners? So I'm giving you the area, all right? We need values. So let me make a note here. So we need a value. Pretend that says need a value. Not an area. All right, so that's going to change our drop down. So if you're doing, you'll notice here, these are normal CDFs, right? Here we're changing to inverse norm because we're going backwards. We're going from the area to the value. Same thing for the stapplet. We don't need the area, we have it. We want the value. All right, so I'm going to calculate a value, and it's still the same mean and standard deviation, 63.1 and 4.2. I want the right 20%, top 20%. Calculate value and show labels on plot, and there you go. That matches the answer I have in the key. All right, so 63.1, 4.2 model here with a normal. Or here you go again. This is the formula for the calculator work. You're going to tell me the area, the mean, and the standard deviation, and that's it. You do not need to give me the z-score. Okay. Next question. Let's go to number 3 over here. So now we have a different mean. We have 92.3 and 12.5. And I want the top 10%. So instead of 20%, I'm going to say 10%. It's top, so it's on the right, and there you go. So there's the top 10%, and that happens at 108.3 pounds. All right, so there you go. That is the cutoff for the top 10%. Okay, let's go to number 4 on the right. What is the cutoff for Q3? Q3 is the top 75th percentile. Percentile goes from the left. So if I want to do it as a percentile, I should have left tail and I should put 0.75 in. My other option is I could say, oh, that's just before we cut off the top 25%. So those two answers should give you the same values, all right? So you can look at it as the 75th percentile, which is on the left. Make sure you go left tail and go put 0.75. Or you can say, oh, it's a cutoff for the top 25%. Now let's go to the other side, partner A. What is the weight cutoff for Q1? Again, remember we have a slightly different mean, well, not that slight, a different mean and a different standard deviation, so I need to adjust. I'm looking at the 25th percentile if I'm looking for Q1. Calculate my value, and you can see that it is 60.27. All right, so that's Q1. The next part I ask you, there is no stapplet required. It is, what is the upper boundary weight for a high outlier? Actually, I lied. You do need to do the stapplet. So for this one, I need to find Q3. So I could just switch it to a right tail, and there's Q3, 65.9, which you can see over here. Then I find the IQR, which is Q3 minus Q1, which is 5.6. Then I find the upper boundary by adding Q3 plus 1.5 IQR. For the other one, I ask, what is the lower boundary for a low outlier? So I have Q3, I need to find Q1. So let me put in that mean and standard deviation. 92.3 and 12.5. And I'm trying to find Q1. So this will be left tail, calculate. And there you can see it's 83.9. Okay, so that's my Q1. So over here, I just do Q3 minus Q1, get 16.7. I'm looking for the lower boundary. Oops, I see a typo. So this should be the lower boundary, not the upper boundary. Equals Q1 minus 1.5 times IQR, which is basically 83.9 minus 1.5 times 16.7. It's 58.85. All right, now these two problems reference each other, all right? So we have basically the same information I had on the previous page. Now I've combined them into the two so you can see them both there, all right? So we have 70% are runners and 30% are bodybuilders. So one of the ways you can do these problems is you can do a list or you can do a tree. So you can see my example with a tree on the right, and this is more of a straightforward. So if I did a list, all right, let's say I wanted to find Let me move this right here. So the potential things that can happen are I can have someone who is, so if we did a list, we have 72 plus and runner, right? 72 plus, let me go ahead and do this. 72 plus and bodybuilder, given body. So let me start with this. They're either a runner or a bodybuilder. So they're either a runner at 72 plus. They're a runner and not 72 plus. They're a bodybuilder and 72 plus. Or they're a bodybuilder and not 72 plus. All right, so I'm going to kind of move this around so you can see it a little better. So these are the 4 things that can happen. And that's kind of what, when I do a tree, let me go ahead and do a quick tree. It's not going to be pretty. So they're either a runner or a bodybuilder. So there's my runner. There's my bodybuilder. Pretend that's a B. There we go. There's a B. And then they're either 72 plus or they're not 72 plus. You could say 72 minus, or you could just say not. As long as you know what N means, all right? Only reason I'm doing it that way is my hands are, I'm doing this with a regular mouse, so it's a little hard. All right. So remember, a tree is just a list builder, all right? It is nice because you can kind of organize it and put the numbers in there. Now, what do I have going here? Well, I'm trying to find the probability. Let's see. What is the probability a randomly selected athlete weighs more than 72 kilograms? So that depends if they're a runner or a bodybuilder. So for the runner, let's see, this one, if you went to the runner side, well, we had different weights here. So we have to go calculate both of these. So the runner, the probability that they are more than 72 pounds, given that they're a runner, is just 1.7%. How did I do that? I did normal CDF. Lower is 72, upper is infinity, and then the mean is 63.1, standard deviation is 4.2, what we're using on the other side of the page. Bodybuilders are heavier, so I still have the same lower and upper, but my mean and standard deviation change. So most bodybuilders weigh at least 72 pounds. In fact, that's almost a 95% chance that a bodybuilder does weigh that much. So what you can do, let me go ahead and move this here, kind of to the right, is you can basically take these lists. So runner and 72 plus, right? Well, that's going to be the probability of that. Let me go ahead and just write the probability. Is basically probability of a runner, which is 0.7, times the probability that they weigh at least 72 pounds. Well, we found out that was pretty small. All right. And then probability they're a runner and not 72 pounds, at least 72 plus, right? I could just say that is still 0.7 that they're a runner, and it's 1 minus 0.017. All right. Then the probability they're a bodybuilder, whoops, sorry. And 72 plus is the probability they're a bodybuilder, which is, we said it would be 30% are bodybuilders, 0.3. And the probability of bodybuilders at least 72 pounds is 0.948. And you can multiply those out. And then finally, the probability they're a bodybuilder but not 72 plus. It's still 0.3, but this time it's 1 minus 0.948. All right, so that's going to be a much smaller number. So the two that, if I want to know what is the probability an athlete is at least 72 pounds, I basically just take these two answers. They could be a runner and 72 pounds. See that? or they could be a bodybuilder and 72 pounds. So you take those two products and add them together, and that gives you the answer. Then I asked, what is the probability? I'm going to stay on this one because these numbers are related. What is the probability an athlete is a bodybuilder given that they weigh more than 72 kilograms? I'm going to say it's pretty high because most of the bodybuilders weigh more than 72 kilograms. And we found out that that was, bodybuilder is here, 0.2844 or 49, depending how you calculated it. Wonder why I have a different digit there. I'll have to go figure that out. And so that goes on top, right? So that they are a bodybuilder and at least 72 pounds over the probability they are just 72 pounds. So that number comes from up here. And it goes right there. Okay. Same idea over here. So I don't really have a list. I have a tree and I multiplied everything out for less than 70 pounds. Now, most runners are 70 pounds, 70 kilograms, these poor people. Most runners are less than 70 kilograms, so you see a 0.95 up here. So you get 0.76. Very few bodybuilders are under 70 kilograms. You see that's less than 1%. Add them up. So the probability that they are at less than 70 kilograms is just this 0.7674. All right. And then what is the probability? Let me change font on this so it's at least the right size. Looks better. Let's make this a 16. There we go. The probability they're a runner, given they weigh less than 70 kilograms, is pretty high because most of the runners are pretty light. So that's a probability they're a runner and they weigh less than 70 kilograms over the probability they just weigh less than 70 kilograms, and we don't know if they're a runner or a bodybuilder. You divide those two out, and then you get your answer. So that's it for your review. Hope that helps.